Good morning, students. Today, now I want to explain about the in ionic equilibrium. In ionic equilibrium, now I want to explain what is the pH. Next, we discuss about the different, if it is acidic nature, it is basic nature, if it is neutral, how we find out the pH, what are the ranges of the pH, the effect of temperature on the pH, and also after that we have find out the for acidic for acids we find out the pH, for weak acids we also find out the acid pH value, and also we discuss about the if it is mixture of acids how you find out the pH. Next after that we find you can calculate the basic nature how you find out the pH, and also if it is acid and base if you mix then how can we find out the pH. These are the important concept we discuss in this chapter. Next, first we discuss about the pH. First, what we have discussed. First, we start with the ionic equilibrium. Ionic equilibrium chapter. In this, we discuss about the first what is pH. pH. Next, we discuss about the range of pH and effect of temperature on pH, effect of temperature on pH. Next, third we discuss about the how you find out the strong acids pH calculation. Next we discuss about the if weak acids pH calculation, how to calculate the for weak acid pH calculation. Next for discuss about the mixture of two acids, how to calculate pH, how to calculate pH. Next for mixture of two acids how you calculate the pH. Next for bases calculation of pH, for bases also you can calculate the pH. Next mixture of acids and bases, how to calculate pH, how to calculate pH. In this chapter we have to discuss about these 7 values. First we discuss about the what is pH, meaning of the pH. Next range of pH and effect on the temperature on the pH, how it will affect the temperature. Next to discuss about the strong acids pH, how to calculate. For weak acids pH, how to calculate. Next mixture of two acids, how to calculate the if for single acid we calculate the pH. By mixing of two acids how to calculate the pH. Next for bases also have to calculate the pH. Next mixture of acids and bases, how to calculate the pH. These are the first we discuss about this. Next what is pH? First we discuss about the pH. pH is defined as a negative logarithm of log 10 concentration of H3O plus ions is known as a pH. This pH is equal to negative logarithm of concentration of H3O plus ions is known as a pH. This concentration is taken as a moles per liter. If your concentration of H3O plus ions is taken as a moles per liter, that is known as a molarity. This is the pH definition. Is negative logarithm of concentration of either H3O plus or H plus ions is known as a pH. This is defined as a moles per liter. If it is if you want to find out if it is how you define pH having different concentration of H3O plus is equal to the concentration of OH minus. This is known as a neutral. This is known as a, if it is taken as a neutral solution, there is a neutral. If concentration of H3O plus ions is greater than concentration of OH minus, this is known as a acidic. If it is concentration of H3O plus ions is less than OH minus, is known as a basic in nature. Basic in, this is known as a basic in nature. We know Kw is equal to, this is later we discuss, Kw is equal to concentration of H3O plus minus concentration of OH minus. If it is, this is Kw is 10 power minus 14 at 298 Kelvin. 298 Kelvin. This is taken as x or x square. This is equal to x is equal to concentration 10 to the power minus 14. X is equal to 10 power minus 7. This is also 10 power minus 7. This is also 10 power minus 7. This is the concentration of H3O plus is equal to 10 power minus 7. Concentration of H plus is also is equal to the 10 power minus 7. These are the, this is, if these two are equal, this is at net neutral solution, these two are equal. At neutral, concentration H3O plus pH is OH minus is equal to neutral. For that pH is equal to 7 if it is neutral. If it is concentration of H3O plus is greater than OH minus, it is acidic, means this is 10 power minus 7 is greater than concentration of OH minus. Concentration of H3O plus is greater than 10 power minus 7, means when it is acidic, that is 10 power minus 6, 10 power minus 5, 10 power minus 4, 10 power minus 3, 10 power minus 2, 10 power minus 1. These are the values, means pH values 6, 5, 4, 3, 2, 1, 0. These are the acidic pH ranges for acidic in nature. If it is for 0 to 0, this for this basic in nature, if you substitute here basic in nature, 10 power minus 7 is greater than the concentration of OH minus, less than this one, means that is 10 power minus 8, 10 power minus 9, 10 power minus 10, 10 power minus 11 up to 10 power minus 14, means 8, 9, 10, 11, 12, 13 and 14. These are the ranges of pH for basic in nature. pH ranges for, this is for basic in nature, this is for acidic in nature. pH range from, this is pH range from 0 to 14. Must remember, this is the at 298 degrees centigrade pH. This is the range from 0 to 14. You have to remember, very important, this concept you have to. pH means negative logarithm of concentration of H3O plus is known as a concentration of pH. This is defined in moles per liter. If it is Kw, you know, that is equal to concentration of H3O plus OH minus. Kw at 298 degrees is 10 power minus 14. If you take X, this is 10 power minus 7. Concentration of H2 plus ions and 10 plus H plus ions at neutral. Both two are equal. That for that pH is 7 for neutral solution. If it is acidic, this is the range. If it is basic, this is the range. Total pH range is from 0 to 14. This is about the pH. Next, Next, I will discuss about the pH depends upon temperature. Next, pH depends upon temperature. This point is very you must remember. pH is depends upon temperature. How you know? If it is at 65 degrees centigrade, Kw is equal to 10 power minus 13. 10 power minus 13. Then calculate if it is neutral solution, calculate concentration of H plus and concentration of OH minus. If it is neutral, that is, if you take as X, Kw is equal to, we know formula, concentration of H plus into concentration of OH minus. Kw is 10 power minus 10. If it is taken as X square, means for X is equal to square root of 10 power minus 13, that is equal to 10 power minus 6.5. This is the concentration of OH minus ions and also H plus ions. For this, pH is equal to minus log, negative logarithm of concentration of H plus. This is equal to 6.5 at neutral solution. That's why it is depends upon the temperature. Say at 65 degrees centigrade, the Kw, the product of water, concentration of H plus into OH minus ions, product is equal to 10 power minus 13. Then pH in this case is 6.5. This is at a neutral condition. That's why pH is depends upon the temperature. You must remember, this is very important. Next, we discuss about the calculations of different solution. For example, find the pH of next one of the question I will discuss. Find the pH of 10 power minus 2 molar HCl solution. HCl, you know, HCl is a strong acid. HCl is a strong acid. It completely dissociate. They will form H plus and Cl minus. It cannot come back because this is in the solution. They will give the H plus ions. That is why this is an acid. Initially 0. Initially this is 10 power minus 2 molar 0 0 at final it completely dissociate, means 10 power minus 2 molar 0. In this case, concentration of H plus, how to write it? 10 power minus 2 molarity. We know what is the formula of pH. pH is equal to minus log concentration of H plus, means minus log concentration of H plus is 10 power minus 2. If it comes, there is 2. pH is 2, means this is acidic in nature. This is the calculation for the pH of the 10 power minus 2 molar solution. If you calculate, for example, this is the calculation for this. These are the values you have to remember. Next, I will discuss find the concentration of if you take it as, for example, 10 power minus 4 molar H2SO4 solution. Find pH. This is question number 2. How to find out the 10 power minus 4 molar H2SO4 solution. Here many students did a mistake. Why? Because if you take H2SO4, they will take directly, but it is a strong acid. It completely dissociate. They will form 2 H plus ions plus SO4 2 minus. If it is H2SO4 minus, this is 10 power minus 4 0 0. If it is 0, this is 2 times of 10 power minus 4. This is the concentration of H plus ions is equal to 2 into 10 power minus 4. We have to concentration of H plus ions, we must take this one, 2 into 10 power minus 4, because it is 100%, so give dissociate gives 2 H plus ions. This is, if you take directly this, many students are get mistakes. Then after that we have to substitute. is equal to minus log concentration of H plus ions. This is equal to minus log 2 into 10 power minus 4. 2 into 10 power minus 4. In this case, minus log 2 minus plus log 4. Log 4 means log 2 minus log 2 plus 2 log 2. Here you take log 2 common, 2 minus 1, 1. You take log 2, 0.3010. This is the log 2 value, we know. Log 2 is equal to 0.3010. Log 3 is equal to 0.477. You must remember these values. This is the 0. Log 10, 4 into log 10, 1. 4 log 10 base 10, 1, 4. They did the mistake here. This is 4. 4 minus log 2 value 0.30 means 3.7 something. 3.7. This is the pH of the 10 power minus 4 molar H2SO4 solution. Next, we have to find out the very important problem. I will explain. Then you have to find out the 10 power minus 8 molar HCl solution pH. Normally, how you find out this HCl solution, 10 power minus 8 molar pH solution? HCl is a acidic in nature. It is a strong acid, means it is completely undergo dissociation. Means HCl completely 100% dissociate gives H plus Cl minus ion is in the solution. For this, initially 10 power minus 8 molar 0, 0, 0, 10 power 8 minus 8, this one. If you want to calculate pH is equal to, we know, minus log concentration of H plus. Many students are put directly this one, minus log 10 power minus 8 means minus 8 means 8 means this is basic in nature. This is wrong, 100%. This is wrong. Why? Because this HCl is acidic in nature, but you have to calculate the pH 8 means basic. How it basic? This is wrong because why? What you have to consider? This is a 10 power minus 8 is a very dilute solution. Very dilute solution. That's why we know H2O is dissociates to give H plus OH minus ions in the solution. We know there is a aqueous. This is taken as a aqueous. What are the concentration of this H plus 10 power minus 7? This is also 10 power minus 7 at a 298 degrees centigrade. All these are calculated. Compared to 10 power minus 7, 10 power minus 8 is very less. You have to add this concentration also. For this H plus, you have to add H plus concentration from water. Why? Because this concentration automatically in the solution H plus ion concentration is there. In case of concentrated like 10 power minus 2, 10 power minus 3, 10 power minus 4, like these solutions we are neglected because this is very less. But in case of this very dilute solutions, we have to add this concentration also from water concentration also. Why? Because this is concentration is considerable, but in this case this concentration is very 1000, 10,000 times or less. That's why we have to neglect it. But here we have to add total concentration of H plus is equal to 10 power minus 8 from HCl solution plus 10 power minus 7 from water. Then we calculate the pH. Then we get the correct answer. How? Then we have to calculate pH is equal to minus log concentration of 10 power minus 8 plus concentration of 10 power minus 7. This is equal to, if you take how to write it, if we put this 10 power, this is taken as a 10 power minus 7 into 10 power minus 1, you have to write it. What is common? Minus log 10 power minus 7 is common. 10 power minus 7 into this is 1 plus 1.1. This is a plus b, means 7 minus log 1.1. 1.1 minus log 1.1, this is equal to 7 minus log 1.1 means log 1 value is 0, but 1.1 means 0.1 something, means if you would get this is 1.04 something, 1.0 something minus, that's why it will get 6.96 like that. This is a acidic in nature. This is the explanation for this. If in case of 10 power minus 8 molar HCl solution is taken and solution is plus, these very dilute solutions have to consider the concentration from water also, otherwise it is very less. Next, we discuss about the calculation of pH. So far we discussed what is the pH. Next we discuss about the for acidic solution, for very dilute solutions, also how to calculate the pH. Next we discuss about the calculation of pH for weak acid. For weak acids, how to calculate the pH. Calculation of pH for weak acids, how to calculate. For example, if you take for weak acid, any weak acid you take HA, weak acid, it is not undergo complete dissociation, it undergo partial dissociation, we know, means H plus plus A minus. This is at initial. What will happen at equilibrium? Initially you take this concentration as C. Initially you take a concentration is this is C. At equilibrium, what is dissociated? C minus C alpha is dissociated. This is already this concept explained how it is dissociated alpha in the chemical equilibrium. For degree of dissociation at that time, I will explain already. What is, once again I am now also I will explain. If you take for example weak acid HA, H plus A minus, take H plus A minus. In case of 1 mole 0 0, if it is 1 mole dissociate alpha is must be less than 1, equal to 1 or less than 1. Equal to 1 means 100% dissociation, less than 1. For weak acids very less than 1. If it is 1, if you take this is HA, if it is 0.4 concentration, then how much will you dissociate? 1 minus 0.4 into alpha. If it is taken as a HA is taken as a C alpha, 1 minus 0.4 minus 0.4 into alpha, not like that. If it is C concentration taken, C minus C alpha is dissociated. Similar like that. Here, if this C concentration is there, it is C minus alpha will be dissociated. For this, you write the Ka, equilibrium constant, Ka, acidity constant. This is equal concentration of H plus into concentration of A minus by concentration of HA. This you know. If it is concentration of H plus is what is C alpha, A minus is C alpha by C minus C alpha. Then you take C common, C square alpha square by C into 1 minus alpha. C will get cancelled, that is equal to C alpha square by 1 minus alpha. This is the K. 1 minus alpha is very less than 1, means here dissociate up to 0.05% only for weak acids. This is taken as a negligible. 1 minus alpha is approximately equal to the 1, means 1 minus alpha is approximately equal to 1. Compared to 1, this is 0.05% means very less, that's why taken as a 1. Then in this case Ka is equal to C alpha square. Alpha is equal to square root of Ka by C. This is the alpha is the degree of dissociation, we know. For this, if you want to calculate the concentration of a pH, concentration of H plus is equal to concentration of C alpha. If they will give us concentration of C, they will give the alpha, then we have to find out the concentration of H plus. By using this concentration of H plus, we know pH is equal to minus log concentration of H plus. This is the equation for calculation of, if they will given any weak acids, you can calculate this like this. This is very important. Next we have to solve the problems. Based on this, we can calculate the problems. Find the pH of acetic acid if it's 0.02 normal, it is 2% ionized. What is the pH? What is the pH? Find the pH of acetic acid if it is normal. If it is generally we can concentration, we can most of the cases we can taken as a normality. We know that is normality is equal to molarity into X factor. You know, here there is no only one. That's why normality is equal to molarity. X factor is 1. That is equal to 0.02 normal. If it is 2% ionized. In case of, write it, concentration of CH3COOH, it is partially dissociated, they give CH3CO minus plus H plus ions. We know they have given the, what is alpha is equal to 2% means 0.02. This is alpha. C has given C also 0.02. We know from before this we already discussed concentration of H plus is equal to C alpha. C means 0.02 into 0.02. 2 to 4. 4 into 10 power minus 4. This is the concentration of H plus. From by using this, how to calculate pH is equal to minus log concentration of H plus. What is this? 4 into 10 power minus 4 means 4 minus log 4. 4 minus log 4 value, what is 2 into log 2 means 0.6020. How much? 3.40. 3.4. This is the pH of the acetic acid. This is the pH of the acetic acid. This is for weak acid. By using this, we can calculate easily any weak acids. You can calculate the pH of the solution, either Ka or whatever it may be, you can find out easily. For bases, how to calculate? So far we discussed for acids how to calculate, for weak acids how to calculate the pH. Next we have to calculate the for bases. For bases, how to calculate the this one. If you take 0.1 molar sodium hydroxide, calculate the pH. We know first we have to find out the pOH, because concentration of OH minus means pOH. This is, we know log OH minus and concentration, pOH is equal to minus log, what is 10 power minus 1. 1 minus 1, this is 1. This is pOH is 1. This is pOH is 1. pOH, don't confuse, this is pOH is 1. But we have to calculate, we know pH plus pOH is equal to 14. This is, we know, they have given pOH is 1. pH plus 1 is equal to 14. pH is equal to 14 minus 1, that is equal to 13. 13 means it is a basic in nature. pH and pOH is equal to 14. This we have to remember at 298 degrees centigrade or 298 Kelvin or 25 degrees centigrade. This you have to remember. This is for basic. This is first we have to convert to pOH, then after that we have to convert it to pH. Then we can solve the problems easily. Next, discuss about the for basis also we can calculate very for the dilute solutions we have to add the concentration of OH minus 1. Same if you take for example if you take in case of dilute solutions, similarly I'll explain for basis also we can write like that. Next, for mixture of acids, for example in case of mixture of acids, how to calculate the pH of the solution. For example, if you take first we can take 10 power minus 3 molar HCl 1 liter plus 10 power minus 2 molar HNO3 for 2 liters. How to calculate the pH for this mixture? If you want to calculate, molarity is equal to number of moles per volume. If you want to take number of moles is equal to molarity is 10 power minus 2 into 1 moles. Or in this case 10 power minus 2 into 2 liter means this is number of moles. Number of moles is equal to 2 into 10 power minus 2 for this case. Total number of moles is equal to what is? Total number of moles is equal to total number of moles. Total N is equal to 1 plus 3 into 10 power minus 2. Molarity total is equal to total number of moles by the solution. Total number of moles by total volume. Total volume. Total number of moles how much? 3 into 10 power minus 2. Total volume how much? 1 liter, 2 liter, 3 liters. 3 gets cancelled. This is 10 power minus 2. This is the concentration, total concentration of H plus in the solution. Then pH is how much? We know pH is equal to minus log concentration of H plus ions, means minus log concentration H plus is 10 power minus 2, that is 2. This is the normal procedure for calculation of the equation. For in case of this one, shortcut formula, that is total concentration of H plus is equal to, it is M1 V1 plus M2 V2 by V1 plus V2. This is the formula I have to remember, very important. In order to solve trace out derive this one, you can directly substitute it or not, find out. M1 is 10 power minus 2 into 1 plus 10 power minus 2 into 2 by 2 plus 1 means 3. Means this is 3 into 10 power minus 2 by 3. 3 get cancelled, 10 power minus 2. Then we can get directly also. We can by directly substituting in this equation also we can get, or by solving this like this also we can get the concentration of H plus in case of mixture of acids. This is also very important. Next, we will discuss about the next for the that is applicable for monobasic acid. You must remember strong and monobasic acids only, not for other acids. If it in case of this is calculated for acids, if you want to if you want to calculate for if it is mixture of acid and base, if you, for example, if you put mixture of acid and base, how to calculate? Next, last concept, that is calculation of pH for mixture of acids and bases. How to calculate? For example, if you take one of the example, that is 10 power minus 2 molar HCl mixed with, that is in 2 liter vessel, 2 liter solution, then mixture with 10 power minus 3 molar sodium hydroxide, that is in 1 liter. Then calculate the pH, acid and base. For this, how to calculate concentration of H plus? First we have to calculate concentration of H plus. Number of moles of H plus. Number of moles H plus means 2 into 10 power minus 2. Here number of moles of OH minus ions. OH minus is 1 into 10 power minus 3. This is number of moles. 1 liter to 10 power minus 3. Which one is bigger one? This is the concentration of H plus is greater than concentration of OH minus, means this is acidic. This is acidic, somewhat acidic. That we know. That is acidic. That is acidic in acidic, we know. This is acidic. Acidic means how to calculate? This is means concentration of H plus is greater than concentration of OH minus. Means resultant is concentration of H plus ions. Then we have to resultant is H plus ions. Number of moles of H plus is equal to 2 into 10 power minus 2 minus 10 power minus 3. How much? If you want to calculate 10 power minus 2, you multiply with 10. This is also 10, this is also 10. 20 into 10 power minus 2, 10 power minus 2. 10 minus, or this 20, if it is taken as, if you want to multiply with 10, what is happen? 20 into 10 power minus 2, here also 10 power minus 2. 10 power minus 20 minus 1 means 19 into 10 power minus 2. This is the concentration of number of moles of H plus ions resultant. Total how much? Solution is 1 liter and 2 liter. No? That is concentration of H plus is equal to total resultant 19 into 10 power minus 2 by total volume, that is 3. 19 by 3 into 10 power minus 2. By solving this equation, this pH value, you can calculate the pH of this solution. Otherwise, if you want to calculate resultant solution concentration, if you want to calculate concentration of H plus is equal to M1V1 minus M2V2 by V1 plus V2, or acid, this is base, acid volume, base volume. This is the resultant. What if it is acidic or basic? Which one is the resultant? We can write there. Then we can get the, if it is basic, concentration of OH minus, base front side and back side. Then by using this, we can calculate the concentration of either acid or bases. This is about the so far we discussed about the calculation of the pH. What is the pH? How to calculate the pH for dilute solution, and also pH depends upon the temperature, and pH calculation for acids, strong acids. After that we calculate the dilute acids. Next after that we calculate the for weak acids, how to calculate for bases, for weak bases. If mixture of 2 acid and base, if it is mixture of 2 acids, if 2 bases, by using different methods we can calculate the pH. Next we discuss about the, later after that we can discuss about the Ionic equilibrium, acid base theories. That is in the next class. Thank you.